All right, let's do this. Let's get started. People will trickle in, but in the meantime, I'm going to set us up with the link to the thing. Everything's all in here. Let me know if it's not working for any reason. And again, we'll start slow because I anticipate people just kind of drifting in, and so want to give them an opportunity to catch up when they get in. If you're joining, use the link in the chat. It's going to take you to a public collaboratory file, and just holler if you can't get in there. And we'll be talking about this momentarily, but collaboratory, I'll just call it collab, is a notebook where you can write code. And the cool thing about it is just that since Google, I think, acquired it, it's literally something that you can just use from Drive, including reading and writing data, which we'll definitely be talking about. But you can also share it just like any Drive file. So the nice GIF, Olivia. The thing about it is like basically setting up an environment where you can actually do computer coding stuff is historically always the hardest thing. And with Collab, it's not hard. You just, it's in the cloud, it's in the browser. And since we probably have most of the folks who are going to join, welcome. And I will explain a little bit about the first time setup. So I'll just kind of vamp a little bit and go slowly because I'm sure one or two more people might trickle in. But the basic gist of it is you have to install Collab. It's not like automatically part of Drive, but it's super simple. There's 2 screenshots at the top of the notebook that will show you how to do it. I'm assuming you can see the notebook before you install Collab. But if I'm wrong about that, let me know. Okay. So the error message in the notebook, there could be some like errors like later on, but we're kind of going to start at the top. Are you able to actually see the notebook? Oh, there's an error loading this notebook. Ensure that the file is accessible. Okay, you can't see it. Okay. Let me double check here. Make sure that I have sharing on. Anyone on the internet with this link can comment. So let's try this first. I'm going to walk y'all through how to install Collab. That might be the issue. Just realize that if you don't have it installed, it might be hard to view it. So from Google Drive, if y'all can just follow along as I just talk through it, I promise it's a 2-step process. From Google Drive, when you click the plus button to add a new thing, you go to More, and then Connect More Apps. Why don't I share my screen and you can watch me do that? More, and then Connect More Apps. And when we click that, you can type Collab with just 1 L. It'll autocomplete Collaboratory. And I've already got it installed, but you need to install it. It'll take like 2 seconds. It'll make sure that you actually want to install it. The thing about Collab is it can read and write files to your Google Drive. So only install it if you really trust it. Otherwise, feel free to just watch. This is kind of designed to be a little bit more of like a watch and learn and ask questions thing. I'll try to stop and answer questions if people get stuck on anything, but suffice to say, if you get like really stuck, the point of it isn't necessarily for everyone to do this together all at once, because that's just kind of hard to do on a virtual platform. Instead, I would suggest if you start getting stuck on things to just kind of follow along, and it's better to get the broader points of what we discuss here, rather than try to keep up with the typing and debugging stuff. I think if, given 1 hour, you might miss some of the bigger picture things if you focus too much on the details. But hopefully this will get you to the point where you can open a Colab notebook in your Google Drive. So if folks do that, I'm going to stop sharing for a second so I can kind of keep an eye on the chat. Could I just generally get like a thumbs up if people are able to install Colab? Okay. Hey, Olivia, do you want to jump in and join, and we can talk this out a little bit? No worries if you can't or don't want to. And we can try for a couple minutes to get this, and then I'll just kind of go ahead with the presentation, and hopefully it's informative either way. Hey, Olivia.
Hey, can you hear me?
Yeah, I can hear you.
Okay, I think my video is slowly coming in, but okay, so it looks like I installed Colab,
Okay.
and then went back to the link, the tiny URL,
Mhm.
and it gave a notebook loading error,
Okay.
stating there were invalid credentials.
Okay. Yeah. This could have something to do with. Tell you what. So this sounds good that we actually have people in Colab. I think what we can do is folks can try to type the stuff that I have in the notebook,
Okay.
and I can try to make this. I can try to share one more time. I think I have anyone on the internet with this link can comment. So let me just copy the link and put it in the chat, see if that works. Yeah, Don's got the right idea. It's totally fine to just watch. But Olivia, let's try this one more time. Can you click on this Colab link and see if it works for you?
I clicked on it, and yes, it does work.
Oh, okay. I might have goofed the share link that I made into a tiny URL. So that's awesome. We're in. Okay, cool. Thank you, Olivia. I'm
Thank you.
get right to it.
All right.
Okay, cool. So I'll share screen. So figure out what you want to do, because I'll have my screen that's going to have some code on it. Y'all will have your own Colab notebook if you have two screens. Awesome. If you're on one screen, you might want to like split screen so you can kind of watch and do at the same time. I'll do my best to keep an eye on the chat. Olivia, you're welcome to like jump right in if things go really off the rails, because you're the only one who can like jump in and talk. Otherwise, I'm gonna get it started. Cool. Good to know, Michelle. All right, let's dive right in. Tried to make this as simple as possible. So the purpose of this presentation is to learn a little bit of Python, so you can see how this would apply to public records research. And I was just kind of thinking about it like, oh, this isn't FOIA at all, right? Because if you're doing web scraping, which is the example today, by definition, like you don't really have to FOIA for stuff that the government puts on the internet, right? But there's important stuff that you can learn about public records, which is the point of FOIA. You can also learn a little bit about data sets in a way that helps you write a FOIA, because you see like what's missing, or maybe like if there's some clues that there's more information available. And finally, I'll just mention with like the dashboardification of government, as you've noticed with like coronavirus stuff or like just general data portals, the snowplow tracker in the city of Chicago. There's all this bulk data sitting out there on the internet. And to be quite honest, in my experience, this stuff does not get really retained. Like some of this streaming data, especially like the snowplow tracker. I work at WBEZ, by the way. We tried to FOIA the snowplow tracker data. They don't have it. It just, goes right down the memory hole as soon as the GPS sends a ping. It gets published on the web. A few minutes later or whatever, when the new data comes in, the old data is gone forever. So unless you're like scraping that, like basically suffice to say, in the Venn diagram of like, public data, like web scraping is an important thing that has like minimal overlap with FOIA, but there's some important like stuff there to keep in mind. So we're going to talk about the Chicago Public Schools coronavirus case tracker, API, just because it's something that I've been working with a lot at work, and I think it's a good example. Y'all might want to click on this link for the story. It's a Twitter thread that if you're from Chicago, you probably remember this from a few weeks back when someone caught a difference between what the CPS dashboard public-facing website thing said in terms of the number of cases and how many cases were getting returned when he pulled data from the API. And so I found that interesting. I was also looking at that data and also kind of puzzling over what the reason for the difference was. And I think that this is a really good example of public information and different ways to view it. FOIA is not going to tell you everything. Neither is web scraping, but having the two together is a really good start. So encourage you to read that thread and Google it a little bit if you're not familiar with the story. But we are going to, by the end of this, be taking a look at live data off the CPS COVID tracking API. And for those of you who are unfamiliar, API is an application programming interface. It's basically a way to write code so that you can have one computer program talk to another one on an automated basis. The example being wbez.org/COVID in schools, where we have a tracker of all the education, all the COVID in schools data, case counts, outbreaks, exposures, vaccination rates, what have you. Most of this data is automatically scraped every day or every hour. And so this is an example of what you might use an application programming interface for. Is we don't have to update this, it updates itself. So hopefully that's a good example. I'm just going to pop in here and see if there's any questions. And great. Okay. Olivia, if you don't mind keeping an eye on the chat, and if there is an urgent question, just please feel free. You can pop in anytime. Okay, so I'm going to give you some examples of what computer programming can do. Python's one language. There are many others that are similar to it, and this one is the easiest. And thanks to this collab, it's even easier because you can just pop open a browser window and start hacking. So Python can do math. This is an example. Anything, by the way, with a hashtag is going to be a comment. It's not executed by the program, which is great because you can use it to write little notes to yourself so you can remember what the reason for the next line of code is. So you'll see that throughout. Python can do math. When I hit enter on this little math equation here or whatever, it's going to give me a result, 101. Python can basically understand text as the things between quotes. Doesn't matter if it's single quotes or double quotes, just make sure they match. That makes sense. So that's a text, or you'll hear me call it a string, which is text. You can assign variables. And just in case folks are not familiar with it, these are the inputs with the black background. That's what I type. And then on the gray background, that's what the computer gives me back. So I type the command, I get the response. So here, when I say city equals Chicago, and then hello plus city, see what happened here? The plus sign is not just for math, like 100 plus 1 is 101, but you can also say hello plus Chicago and get one string that's basically a combination of two other strings. Okay, moving right along. So those are variables. We'll get into lists and dictionaries, and then I'll ask if there's any questions, because this is where it gets interesting. So this is my list. It's a list of bulls. So there's Kobe, Io, Damar, Javante, and Nicola. Okay, pretty simple, right? This is a list, and I'm just going to play around with a little bit more code here because I want to show you a little bit more about lists. If I want to get the length of this list, is how many items are in it. It'll tell me that. If I want to get the first item on the list, I can do this little bracket thing and say, give me the first one. And in Python, they start counting from 0. So that'd be bowls 0, and this is going to return Kobe. Okay. I can get the last item on the list, which would be -1. This gets a little confusing, but you see the point here. A list is multiple things. It doesn't have to be strings. All of these are, but yeah. You can add to a list. So we'll add Tristan to the bowls, and now the bowls have Tristan. Cool. Okay. I'll ask for questions after we get through dictionaries, because dictionaries are similar to lists. Dictionaries have multiple items, but the thing about dictionaries is they're kind of two-dimensional. It's a key value pair or a series of key value pairs. So for guards, we have Kobe, and we have a list, Kobe and Damar. For forwards, we have another list, Nikola, Tristan, and Javante. And then for mascot, we just have Benny. So you notice this is a list, this is a list, this is a string. There's no specific type that's required. So hopefully folks are getting that there's different types of objects in Python. There's strings, there's numbers, there's lists, there's dictionaries. Those are kind of the main ones. And so that's a good point to kind of pause. I will just demonstrate really quickly, though, one more practical application of dictionaries is that you can call these items. It's doing a little autocomplete for me here. But if I do bowls lineup mascot, that's what's going to happen next. Get Benny back. See how it looked up? It said, oh, you're looking at bowls lineup, and you want to know the mascot. That's Benny. I hope that made sense. This is a good point to pause. Let's stop the screen share and just ask if anyone has any questions or a thumbs up if you feel good about what you're learning so far. And feel free to mess around in your own Colab notebook now that you have access to that. You can look at mine, and you can also like create yours and kind of play around with it a little bit.
Seems like everyone is experts with you on this ride.
Yeah, feel free to just put in a question mark if you're totally, just like, can you repeat that or whatever? Like, but it seems like everybody's so far so good. Okay, cool. I promise this is really important. Dictionaries are like, I think, the most important thing, just because you can organize your data, and I'll switch back to the screen share. You can organize your data like very specifically and label things in a way that's very easy to grok or like understand. Dictionaries also, if we'll get to this, but dictionaries are essentially JSON. If you're familiar with JSON, or if you've heard the term before, it's kind of like the anti-spreadsheet. It's not a table. It's shaped like this. So basically key value pairs allow you to kind of make up the data as you go along, which is very flexible. There's no limit to like what you can put in here. You can have lists of dictionaries, and basically most of the data that moves through the internet is packaged up in JSON. And that's how you kind of like get two computers to talk to each other, is quite often, like most of the time, programmatic, like automatic data transfers. A lot of it's going to be in JSON, and JSON is basically lists and dictionaries. So this is kind of like the key to like understanding programmatic data on the web. Okay, cool. Hopefully that's useful. I have to go over a few other things that are just like so important, just can't skip it. In Python, the code that you use on your screen isn't just like the code you typed. You can also import like whole packages of code. You might hear them called packages, or more likely modules or libraries. It all kind of basically means the same thing, like a big bundle of code that comes in like one quick line. So for here, I need to, like, for purposes of this example, use a date and time. And so I have to import that. That's not like a standard thing. You have to import it specifically. So from date time, import date. Basically, date time is a collection of modules, and date is one specific one. It's kind of like saying, go into this folder and grab that file. That's almost exactly what it's doing. And so I can add, for the purpose of this example, this Bulls lineup dictionary, I can assign a new item to the dictionary. Bulls lineup next game equals date today. And now add a little demo code, Bulls lineup. You can see I have my forwards, my guards, my mascot, and my next game, which is not a string and not a number. It's a date object. Didn't really talk about objects much, but suffice to say, I probably will talk about it a little bit more, but objects are very much like, they're variables. So it's basically assigning some data to a name so that you can retrieve it later. The cool thing about objects in Python or objects in most programming languages, is they can have attributes. And so you can basically give more data to different names, within an object. So I could create like an object that could have like, a height and a weight and, different attributes that I could assign. And so it's just kind of a way to keep your data organized and have like a naming convention. We won't talk about them a whole lot, except that it'll come up like towards the end of this walkthrough. I'm just gonna check how we're doing on time. We're doing great. Okay, cool. Remember to add your questions when you have them, and I'll circle back there every few minutes. Errors are important. Errors, they happen. It's life. So errors are when you do something that the program doesn't allow you to do. And it's just going to happen. So we may as well talk about it. Like how do you resolve an error? So I just made a intentional error here. I'd shown you before that you could combine numbers and you can combine text, but you can't mix and match. So here I try to combine text and a date, and that's just not allowed. So I get an error, type error, what type of data it is. So type error, you can't combine string and dates. But I could change this a little bit, and I could say, take my date, make it a string. Yeah. 226. They do play tonight. Who do they play? Just gonna check. So any questions on that? Okay, cool.
No questions so far.
Awesome. Ooh, the Bulls play the Grizzlies, and the Grizzlies are good. Okay, cool. So another thing, and this is the last like conceptual example, and then we're going to go back to that actual case study of CPS COVID case data, and that'll be the bigger point to this. But just want to show you one other cool thing, which is a function. And a function is yet another way to kind of shorten up your code so you don't have to retype the same stuff over and over again. If you found yourself in your program like adding two numbers together over and over and over again, you might just create a function that does that for you, so it's less typing. So this one's pretty straightforward. I'm defining it with this name. So I'm calling my function add1. I could call it whatever I want. And then these parentheses are where I can put like some kind of argument to pass into the function. Excel is kind of like this. Like if you sum, it wants to know what you're summing. And so this is where you put your argument. The colon here is just a convention to say that the code follows right after this line. Also in Python, there's like an indentation thing where you have to indent whenever you define a function or go through like a loop or something like that. We'll talk about loops later. So all this function does, if you couldn't, sort of tell, is it takes whatever you give it and it adds 1 to it. Thus the name add 1. So if I call this function later, now that I've defined it, I can use it. So if I add 1, 19, I get this result. Obviously, functions can be longer. It's good for them to be short because that means that you're using them very intentionally for a specific purpose, which always ends up being like best for reusability. If you have a really long function, that probably means you're, not taking advantage of like how useful and repurposable these things are. Smaller pieces are easier to fit together, I guess, is one way to put it. Checking if there's any questions. No questions. Okay, great. So here we go. We're going to actually scrape some data here. I am going to start by importing a couple of new things that I need to scrape data. The first is requests. This is how you get stuff off the internet in Python. It's one way. It's the simplest way. So requests can get things, and it's literally as simple as getting a URL. So data equals requests.get this URL. Where did I find this URL? It's a good question. It came from the CPS Public Health API, which is helpfully on the internet and documented. And it basically tells you, here's what all these URLs are and what you get when you request them. You can actually, it's as simple as if you want to try it before you buy it, you can copy this URL and paste it into your browser just to verify that you got the right address, and you will see the data load on the screen. One very weird thing about this is that when you pull this URL up in a web browser, it comes back as XML. If you're familiar with it, you already see it. It looks like HTML. It's a markup, extensible markup language. You'll notice that it doesn't look like a dictionary. It doesn't look like JSON. And that's weird, but I'll just tell you that when you request it via Python, trust me, it gives you JSON. So it's just kind of strange that it gives you one format if you use a browser and another format if you use a computer program. So anyway, suffice to say, you get all that data back when you do data equals requests.get. So if you can see, like, just to go over this again, because this is kind of the critical point here, requests get this URL. Now I have the data. And I can kind of mess around with this just to show you. But first, I'll just walk through the next 2 lines. When you do a request for something on the internet, there's different things that come back, like a status code, like 200 means you're good to go. 404 you might be familiar with, means like does not exist. 403 means you don't have authorization. 504 means the server's broken, et cetera, et cetera. So I don't really care because I feel like I got this right. So I'm going to skip like the metadata and just go straight for the content. So I just called it content. I can kind of show you actually. Typing in data, it shows that the response is 200. Data.content. This is the JSON. As you can see, it's not like broken out onto separate lines, but you can see that it's a list that contains a dictionary with a key adult case count and a value of 7, another key of child case count, a value of 16, etc., etc., date stamps, last updated. And because it's a list, there's actually multiple dictionaries. Every dictionary is a date. And you go through 200 days of school that we've had so far this year, and that's all the data. And it's all right there, and it loads pretty fast. So that's the content. Json Data just basically makes this. JSON loads will load a string and make it into JSON. Content here is actually a string. As you can tell, it doesn't start with the list or the dictionary. It starts with the quote. And the quote sign just tells you that this is all actually a big block of text as far as Python is concerned. But once you load the string into JSON, it's actual data. So now JSON data, this is like a Python dictionary. And you can see each key value pair for every day. We just went through a lot here. So I'm just going to back this up real quick and remind you that this is JSON can be like a list, a dictionary, or a combination of the two. Quite often it's a list of dictionaries. And since it's a list, I can just grab the first thing in the list and I'll just get 1 day of data. And it happens to be the most recent day, which was yesterday, Saturday. So I could also get the first day of school by going to the back of the list. I get 829. And if I want to go down a little bit further, I take the first thing and then I get the case count. See what I did there, but that's the first thing. I want to know the date of it, so I go to case count. I'll get this. I hope that makes sense. I'm going to check for questions now. No questions. Okay, cool.
And Matt, we're after this, you're getting to the CPS tracker.
Yeah, this actually is the CPS data.
So that's okay.
That is the data. Yeah.
Wow.
So yeah, I'll kind of show the thing again, because I mean the nice thing about it is every single, it's a 200 item list, one for each day, but they all look the same. They all have these like 15 keys. I could zoom in just for a second here so it's like a little easier to read. But you can see it's the types of things you'd expect. The number of adults who were tested, the number of cases, the number of self-reported. Obviously, since there's 0 tests yesterday, but 7 cases, all 7 of those were like basically a teacher calling in and saying like, I have a positive test or something. The adult test count, yeah, there's a million different things here. And it is sometimes confusing not knowing exactly what they mean. So it is important to be in touch, just like with the FOIA. Same goes for an API. Like, know what you're looking at. And if you don't know, write down your questions and take them back to the agency that owns the data. That's just kind of like the best way to make sure you know what you're looking at. So since there's no questions, I'll just go right into the analysis part, which I didn't do ahead of time, so we can just sort of figure it out. I'm very curious because the spoiler here is that when, and you can read more about this in the Twitter thread and just by kind of searching up CPS COVID dashboard and all the news that came out in January, but it's always been kind of mysterious. I think part of it is because CPS changes definitions of the data. In fact, just yesterday, as we were updating our COVID in schools tracker, we noticed that there were some release notes down here dated Thursday that's pointed out these 7 changes to the data that completely changed like what we were looking at. They basically said this means this now, that means that now. And on top of that, they made another change that's not even listed here. So it was a bit of a guessing game. And I guess the point of this is if you read that tweet thread, that there's no way you could keep up with any of this without looking at this data. If you're just looking at the dashboard or you're just, FOIAing, you don't get to see this. And the important thing to note about an API is APIs are great for journalists and, the public to look at stuff, but that's not why they set it up. Their API is actually, in most cases, like powering their own dashboard. So their dashboard is basically just an empty graphic that calls the API to get their data. I'm trying to explain this, but I think a visual would be better. So when you see the district, you see how that's loading these cases for CPS, and then it renders this chart. That loading was because it was calling this data. So it uses its own API, most likely. I mean, I'm just guessing here, but that's like 100% like the reason most organizations will set up an API is so they can power something like this, like a lookup web page that's human friendly, and this is like computer friendly, if that makes sense. Cool. So one thing I noticed was that, what was the thing that we used to be looking at? Total case count. I think we used to look at total positive count, and you'll notice that total case count is higher. So I think CPS kind of changed around the definitions a little bit about which one is the actual like case count. And it turns out now that it's this total case count. So I'm curious, like I look at, in order to kind of sanity check, make sure that we're getting something consistent with what CPS has, although that's not always the point, especially when you're trying to fact check data sets. But it is a good sanity check to say, hey, do I have the same number as CPS? So on wbez.org, we've listed 17,061 total cases reported or tested, all the above, I believe, at CPS schools since August 28th, 17,061. When I go to the CPS dashboard, they don't sum them for me, but that's, let's see what this is, 11,9, that's 50, 70, 1761. So we get the same number, which is, good. It shows that we're counting the same thing that CPS is, although again, that's not always the point. You want to do your own counting, but it's a good kind of verification to see that you have the same number. So if I wanted to get the number 1761, I would have to count all of the cases, total case count, going back to the beginning of the school year. And that's actually really easy to do. And so I'll start by creating a counter. The counter is going to start at 0. And I'll say for day Json data. I didn't talk about loops yet, but we're about to do it. So I'll talk about it as I do it. For and in are like keywords. So they're like highlighted in a different color here to signify that these are important and they mean a certain thing. Json data was defined already. That's the roughly 200 item list of COVID case data. And day is just a variable that I'm creating on the fly. I create it as I call it. So for day in Json data means day, for instance, like each item, I'm going to call that day. So I'll show you by doing it. Counter plus equals, that just sort of means like add this. So counter plus equals day. Going through a lot here, but I'll circle back. Total case count. Let's just like stare at this for a second, because I think that's like the only way to really get it. Counter equals 0 for day in Json data. Counter plus equals day total case count. So it's basically saying for every day in the data, add the total case count to the counter. And since it starts at 0, the thing about a for loop is there's 200 of these, let's say. So it goes through and it does this once, and then it repeats like 199 more times. And if you're interested in knowing like how fast computers are, this is a very slow speed, low resourced computer, but I guarantee you it's going to chew through this like instantly. So that's how fast Python is. Just went through 200 things in the blink of an eye.
Or less than the blink of an eye.
Yeah. And trust me, this is like, it shows you how much compute power they're giving you here. This is not much. I don't even know how much it is, but it's anything that's free is not going to be like super high powered. So yeah, so this is basically kind of the point of the exercise here. I'll show you one other thing that could be like kind of good homework, because once you have data that you like, let's say scraped off the internet, you might very likely want to save it. Like sometimes you just use it, like we're using it here. We put it on the server so we can power this graphic. Since we haven't set up yet a way to really like save it, we just kind of overwrite the file every day. But if you were super interested in for fact checking purposes or whatever, you could be sort of like scraping this data every day and then saving it in a separate place. So that way you could, like, if you ever wanted to go back and say, well, how many cases did they report in December? And how come the number went down in January, which is like kind of what happened. If you were scraping and saving every day, you could do that. If you're not, then you can't. Like that's literally, CPS will probably not respond to a FOIA with historic data, because if they don't retain it, and they may not want to, they don't have to give it to you. So again, there are corners of the internet and corners of government like information that are invisible to you unless you're able to scrape it. So that's the significance of this whole exercise. And what I'll do to wrap it all up is to show you how to save this. The one thing about collaboratory is it's just a tiny bit more work to save data, because this isn't your computer. You're on the cloud right now, and so if you were to say, "Oh, save this file," they'll say where, like this, So you have to tell it to save it to Drive, and that is kind of a cool part of this. I actually really like working with reporters at WBEZ, where I can say, "Oh, well, I'll use a Colab notebook, and this can read and write to Google Drive." So I'll say, "Well, put your original data over here." And then I'll take a look at it, analyze it, and I'll put my results, my processed data over there. And so we can both work in our like preferred environment. The reporter can be using like Google Sheets. I can use Python, and we can use Drive to trade files back and forth. They give me the originals. I give them the processed. I have my code here. So if 2 weeks later someone says, "Hey, can you change this?" I can just pull this up, find the line that I need to change, and just run it. It's not like I have to redo much of anything. If the agency comes back and says, "Oh, wait, we have updated data," you just rerun the script, and you can, process the data all in one go. So I'll just double check that we don't have any questions before I do this last bit. Okay, cool.
I have a quick question.
Oh yeah, go for it.
So like, I'm very new to Python. And I was just wondering, in terms of like the production timeline, specifically for the CPS tracker, when you're working with a journalist who's using Google Sheets and you're using Python, like what's the timeline and where you start utilizing Python and like, start integrating the work that the journalist is putting into it too?
Yeah, I mean, I'm not against using a spreadsheet to look around data. It's handy to know what you're looking at, because you can quickly and easily just kind of eyeball it. So it's all good with that. I mean, but there are some things that are kind of a replacement for spreadsheets on the command line, and one I'll just kind of drop in here that if folks are really interested in Python, CSV kit is like a really good first thing to use Python with. And just like the name implies, it's kind of like a toolkit for working with CSVs, which are spreadsheets. It'll even take Excel and make them into CSVs. And it's a good sort of like, you're talking about like the first pass, like inspection. What is this? How many things are in this? What are the different types of things? You just kind of want to get a sense of it. So yeah, to each their own. And that's kind of why I like the drive as like the halfway point where I can do code and someone else can do spreadsheets.
Gotcha. And is the have you used Python for just like unlimited like amounts of data, or and is this as the same speed as you just shared with us?
Yeah. I mean, there is almost no limit to how much data. The thing about it is, I'll show you kind of like a distinction here that makes Python kind of like unstoppable. Is that so right here, JSON data is 200 items long, and this is called like in memory. Basically, I've made this like consume some of the memory that the computer has. If you buy a laptop today, it probably comes with like 16 gig of memory, let's just say. If you tried to load a whole 16 gig file into a variable, that would be it. Your computer would crash because it would run out of memory. And so that's like the upper limit of how much data you can consume at once. But the thing is, you don't really have to consume data all at once. In this case, when I'm looping through JSON data, I'm actually only taking one thing at a time, one day at a time, like one byte of the data, so to speak. And so this doesn't have to be in-memory data. This could be a file reader that reads the file one line at a time. And the point is that you could have a terabyte file, which far exceeds the memory of your computer. But if you only read in one line at a time and do stuff with that one line, like add it to a variable, or, there's obviously more complicated math than just like adding something. But if you're just reading in your data one line at a time, your computer will never crash, because as soon as it uses up this data, throws it out and grabs the next one. So you're never adding to your memory load, and you could theoretically go through a trillion rows of data, and your computer will handle it because it's just doing one at a time.
Cool.
Yeah. Okay, so with the couple minutes we have left here, I'll just leave this as more like homework, but it's good to know how to save your data. And this is the part that actually takes more work on Colab than it would if you were on your computer. If you're on your computer, you could skip this step and go to this. But for Colab, it needs permission to write files to Drive. And so you import the Drive module and you mount it. When you do this command, which honestly, I don't know what it does, I just copy paste it from all my other notebooks, it will pop up a web browser screen saying like, hey, it looks like Colab wants to write to Drive, and it's going to double check with you, like, is that cool? And when you give it permission, now you're allowed to take your data and you can write it to Drive. So I'll just breeze through this real quick. I'm importing the CSV module so I can write a CSV. I'm telling it where on Drive I want it to go. This is actually the base directory on Drive. And then I'm creating a file object. So I open up the path to this file. I'll call it foiafest.csv, and I'm writing. And then sorry, I'm breezing right through this, but this is like copy paste code that you should just kind of like maybe keep around and noodle it over in your own time. But this is a pretty efficient way to say, take that file, make a CSV, write to the CSV with basically like a list of dictionaries, which is what JSON is. Write the header row, then write the data, then close the file. It's important to do. And what happens as a result when I run that is I have a file in my Google Drive that took the JSON and made it into a CSV. So we just scraped this off the internet. This whole thing is like 30 lines of code, including like the example stuff. So yeah, literally the part that scrapes the data is like these 4 lines, and then that's it, just writing that data to Google Drive. So you basically have like a 4-line, plus like another 4 lines. You have like a 10-line web scraper, like literally write 10 lines of code and just scrape the data. That's it. I'm happy to stick around for a few minutes if folks have questions. Feel free to type them into the chat. I hope this was useful. If you want to like indicate like, I don't know what your levels are at right now with like understanding it or just being a little bit lost. I'd be curious to know what people think about this walkthrough. Again, the general idea is to just get the general gist of it. And it definitely takes some repetitions to memorize these things. If you do it enough, you kind of get like muscle memory where your fingers actually kind of remember how to write a for loop, because it's just like, it's kind of like writing your name, like, oh, I know how to write, you know, these things. So I would recommend, I like this approach where it's like minimalist. There's not like a ton of extra code that's like unimportant. I feel like almost everything in here is either a good intro instruction or a practical example of how to get or write data. And so I would suggest, if you're interested in pursuing this, try to rewrite the thing, the notebook, in your own notebook. And if you get errors, fix them. That's like the best way to learn. And if you don't, then you'll have a functioning scraper. Try to tweak it, maybe point it at something else. Try to scrape that. It might just work. You might need to change it a little bit, but honestly, it just might work. You could pull up the CPS API specs, which are linked in there, and you could try to scrape other stuff.
I think Yana has a question about, wondering if there's any good resources online that compile Python commands and general tips that you can recommend, Matt.
Yeah, the title is Think Python. It used to be called like How to Think Like a Computer Scientist. That was like an original edition, and then they later used like Python for all their examples anyway, because it's the easiest language to learn. And so the name of the book is Think Python, and you can get the PDF for free. And what I like about it is similar to this is kind of probably where I got the inspiration, similar to my notebook. All of the examples are very bite-sized, so you're not, probably my biggest pet peeve when learning, and this is why I don't teach this way, is when the coding examples are excessively long and complicated. They're trying to teach you everything at once. It's going to be so much better if you try to learn one little thing at a time.
I mean, you're already very much a whiz at all of this stuff, but like, how long has it usually taken you to like kind of learn or be really familiar with Python?
Well, I was doing this like as a journalist on the side for a couple of years, and I was a little bit frustrated at like the learning curve and how to fix errors. And so I ended up taking a job and doing Python like full time for like 2.5 years. Honestly, it only took about 6 months to just, if you're doing it 40 hours a week, you'll probably pick it up in a matter of like months. Nobody has 40 hours unless you're getting paid. So find a way to get paid for it if you want to do that. And that would probably help out. One thing I didn't really mention, but I think it's in the notebook towards the bottom. Yeah, there's an example of error handling at the very bottom of the notebook, and that's definitely homework, but take a look at that and learn about error handling. As I mentioned, mistakes happen. In fact, they happen all the time. And the actual process of learning how to code is learning how to handle the inevitable mistakes that you make so that you can quickly learn from them and not get stuck. You'll find that the first time you're coding, when you get an error, it could take you like hours to figure out like what's wrong. And then it becomes minutes, and then it becomes seconds. And that's when you start really like being productive, is when you inevitably make mistakes, but then you immediately can fix them. So try to learn how to do error handling. And the thing that I put in there is basically how to look very closely at your error and figure out like what you did wrong.
Cool.
Awesome. Thanks for jumping in, Olivia. This was great.
No problem. I'm glad I learned something too. So I hope everyone, Liz, Yana, Don, name them. Y'all were great tuning in to Matt. This was really cool. Thanks, Matt.
Yeah, I think so. Thanks, folks. Thanks for showing up. This is it. FOIA Fest is over. All right.
Congrats. Thanks, y'all.
Thanks.